Okay, for the last example here, we want to find the acceleration of a 34 kilogram box pictured below. The box is being viewed from above. Now this problem is not particularly well written, so we're going to add some assumptions so that we can go ahead and solve this. So we are going to assume that this is frictionless. And I think that should be enough to get us going here. So we want to assume this is frictionless, and again, also we would assume that the normal force is equal to the gravitational force. But again, this is our this would be another situation where that would be our third dimension. So we're only looking at our north and south and our east and our west. So if we were to draw a free body diagram, so the free body diagram for this would be really simple. We're just going to look at this force to the right and then this angled force here, okay? So we'll call this force 1 and force 2. Okay, but to help us solve, again, it's always really helpful to draw a component diagram. And I'm going to draw this to scale so we have a better picture of what this looks like. So I'm just going to draw my dotted lines. Okay. Which vector should I draw first? Force 1 or force 2? Force which one? So force 1 I would also choose to draw because it's at the angle. So anytime I have a force that is not on my axis, I like to draw that first because then it makes it easy to draw the components, right? And then it's easy to kind of see how they compare to the rest of them. For this particular problem, it wouldn't really make a difference, but it can, okay? So I generally draw the one at the angle first. So here I have 15 degrees. And it is 10 newtons. So I'm going to start here. Newtons. So one of the questions that might come up, like, all right, there's this 15 degrees here. That's why I'm using 15 degrees. You can go ahead and assume that's another assumption then. That would be with the horizontal. So 15 degrees above the horizontal. Okay, so we have our first force here, and then that's 10 newtons. This is 15 degrees. And then our other force is 30 newtons. And then we're going to draw our component vectors. So that's going to end up here and here. Okay, so I said this was, this is F1, this is F2. So this is F1 in the y direction. But we know the equation for the y component, and we actually have my F1 force, and we have the angle. So what is the equation for F1y going to be? 10 sine of 15. So then this equals 9.66. All right, so I know the value of the y component, so I'm going to go ahead and draw the x component. Is this the x component? Thanks. This is 2.59. Does that make more sense? 2.59 newtons. Good? Thanks. Okay, then we're going to draw the x component this time. So this one is F1x, and that's going to equal 10 cosine of 15, and that is going to be the 9.66. All right, so we have our y component, we have our x component, and we have our force 2. Okay, so we have everything that we need to solve at this point. So here's the thing. We're trying to find acceleration of the box, right? The issue that we have is we don't know what direction the total force is pulling the box in, right? We don't know that net force, and we don't know the direction, and until we find those things, we can't find the acceleration. So let's go ahead and find the net force in the x direction. Okay, and we're going to go ahead and make rightward positive x and upward positive y. Okay, so this 30 newtons for F2, is that positive or negative? This is going to be positive. And then the 9.66 for the x component is negative. So I'm going to go minus 9.66 newtons. And then that equals 20.34 newtons. Okay. Now the sum of the forces in the y direction. Well, let's take a look. How many forces do we have in the y direction? Just one. Okay, so that's going to be 2.59 newtons. Okay, now I want to draw your attention to something. These are the components for my net force. So I'm going to draw a sketch over here, and it is just a sketch. But what I'm getting here is I'm getting an x in the positive direction. Everybody see that? So this is my 20.34, and I'm getting a y in the positive direction, and that's 2.59. So my net force is the resultant vector here. Okay, so this is my net force, and I'm trying to figure out the value of that net force. So the value here is going to be the Pythagorean theorem of my two vectors. So I know that the net force is going to be the square root of 20.34 squared plus 2.59 quantity squared. And so the net force is equal to 20.5 newtons. Okay, so 20.5 newtons, so this is 20.5 newtons. Okay, so I have the resultant vector. The next thing that we need is the what? The direction. Okay, so it's always the angle with the horizontal. And I know that because I have the y component here, x component here, I can use tangent inverse of y over x. And then that angle is going to be 7.3 degrees. But what is the question asking for again? So then the acceleration is the net force equals mass times acceleration. So acceleration is going to be 20.5 newtons divided by 34 kilograms, and that equals 0.6, we'll just go 0.6 meters per second squared. So it's going to be 0.6 meters per second squared at 7.3 degrees. Now take a look at our picture. We're going north of east.